Hi guys, thanks for watching again. Today I will be comparing those two candle style LED lamps. These are two of the cheapest E14 Candle Style lamps available here in the Netherlands. And this one came from the Action, costing me less than €4. And this one came from the TEDI, or TEDI, costing me a little more than €5. All other E14 Candle Style LEDs here in the Netherlands are at least double the price. So let's see if these are any good. Both of them are non-dimmable, so let's see what circuit powers the LEDs. Also, I will be using this dubious power meter, which I reviewed in one of my previous videos. And after the comparison, I will crack open both lamps to see what's inside and measure the power per filament. So here we go. First, this TEDI lamp. Let's screw it in. And here we go. I hope you can see it a little good on camera, but let's swing it a little bit. It is actually very good, this lamp. The color is amazing. It doesn't flicker at the 50 Hz rate. This one is very good. I'm turning it off because I'm getting a little bit blinded by it. It's really bright. It's good. The only downside is it's fairly ugly light. The filament is all. It's not straight in the LED. It swings a little bit. It makes noise. But other than that, the light is good. The color is good, and it doesn't flicker. This is an amazing lamp for the €5 it costs. So this one. The other one came from the Action. Let's see if I can get it open. This one is not, it's not the same style. It has this ugly candle style shape, and it says it has a 3.5 watt power rating. This one was 4 watt, I believe, and yes, 4 watt. And this nasty power meter says, I believe it said 3.5 watts. Yes, so 3.5 watt. But then again, I don't know if this sucker is right. So 3.5 watts. Here we go. It's very nice color, and also non-flickery, not even the tiniest bit. But it looks like it's less bright, but the color is a little bit more white. But if I didn't know this was an LED, because when I do not have direct sight at it, I probably would not believe this is an LED. So this is great, and this one, the power rating on this dubious meter says 3.0 watts, if I'm reading that correctly, because I'm a little bit blinded by the light of this. So 4 watt and 3.5 watts. So let's crack them open to see the power per string and per filament, and what circuit powers the LEDs. So let's get this out of the way. Yeah, I'm probably can cut open this, but then again I might damage the components inside, because my guess is there should be some kind of capacitive dropper circuit inside, or maybe just a resistor and a simple capacitor. I don't know. I don't want to damage it, so I'm going to use this duct tape. Well, it's not real duct tape, it's just a cheap clone. Put that on there. And then I can just nicely peel it off. No, I cannot. There we go. This is real nasty duct tape. Oh, the glass is broken. That's... Oh, I didn't mean to break it. I probably should wear gloves. Yeah. Now let's do not use the hammer again. Well, you've seen, if you watched any of my other videos, you might have seen me cutting my own thumb, and I'm not planning on to do that again. So yeah, let's do a little bit more wise. Get some pliers. Yes, there it is. Sharp. Okay, well, at least now there's glass everywhere. Right. Yeah, I'm going to do a very foolish thing. Going to stick this in over here. And, well, at least it's powered out, but I would rather be sure to have this plug over here. So the filaments feel a little bit rubbery, and there's some glass pieces sticking to it. So there it is, and I don't want it to come at me like this, because if it's a capacitive dropper, then this might just be live power, and I don't want that. I don't want to touch that. Yeah, let's see. Let's get my meter. Oh, there we go. It's kind of messy here. Probably should clean up. Put the plug in. Oh. And then I almost blind myself. What should I do? It's around 200, I guess. Stick that one over there. So, put it on, and then a little bit more solid, so it won't move away. What I'm going to do, I'm going to touch this one and touch this one, and probably they're all or I can touch this one, that doesn't matter. And when I do, this one will go out, and here I can read the power going through there. So there we go. But it won't let me. And why is that? Oh, because I'm very stupid, of course, and I should put it in the amp setting. Also, nothing happens. It's not AC, but that wouldn't matter, right? So why am I not measuring any current flowing? Is it just because it's too low? It's milliamps and 200 milliamps. Let's try that. $10 milliamps. There we go. That's what I meant. So 10 milliamps per filament. That means 40 milliamp for the 4 of them. And let's do one final measurement. That's what I wanted to measure also. So the voltage per filament is 70 volt. Let's see if I'm right. This should be 140. Yes, it is. So if that's 140 volts, I cannot see anything anymore. Yeah, I will probably have to pause the video because I'm just blinded by all the lights. So one moment. So I pulled out the filaments and tried to crack open the base, but it isn't very easy. Also, this approach with this duct tape was not the best idea I've ever had. So the next one I will try it like this, and this time, and like the time with the battery, I actually use another plier to hold it and not so that I do not cut myself. So at least there's glass everywhere, so I will be having to vacuum my man cave. Oh, so much for not damaging the circuit. Why is there rubber around it? So yeah. So, would I have damaged the circuit if I cut open the base? No, I would not. What's on here? Does this contain any more glass? So no, so I won't cut myself. A capacitor. All this goo is not making it very easy for me, but yeah, let's get the capacitor away. Sorry, that was a 400 volt, 2.2 microfarad. There is a bridge rectifier, a resistor, and there is so much of this stuff on this board that it blocks my view of how this circuit works. Were there more components on this side? No, probably not. So then there is only one mystery device left. Mystery component, I have to say. Another resistor, a transistor, yeah, impossible to see, but yeah, what it does probably is rectify then. Or before, no, then this is an electrolytic capacitor, and then use this as a smoothing capacitor, and that's probably all there is to it. Yeah, it was very good. It is not anymore, but at least these filaments, I will save them, I will keep them. So let's see if I can crack open this other one. Use a little different approach this time. Then. And do I have another? Yes, I do. I hear the glass cracking. That is a terrible sound. Or is this stuffed all the way? No, it is not. Or at least it doesn't look like it. So, well, is it safe to hold this bulb? No, probably not. Maybe this circuit I can keep, maybe I can keep it intact and then reverse engineer it. There's all kinds of stuff falling out. Somehow it looks like the exact same circuit. I'm not very comfortable holding this glass bulb, but what could possibly go wrong? See if I can cut the heat shrink away. Well, looks a little better. Oh yes, much better. Only resistors on this side. Let's see if I can pry it out. Wow. That's not that bad actually. There we go. A bridge rectifier, a power regulator, and another resistor. It's probably a little hard to reverse engineer, but I'm going to give it a try anyway. I'll be back in a moment. Oh, what? This is a resistor. Before we continue, I really need to know what it is. Well, that would be some inverse limiting resistor, I guess. Brown, black, black. So 100. 100 ohms. Is that correct? Well, I've got this handy. 10 ohms. 10 ohms, okay, 10 ohms. I was mistaken. Brown, black, 10. And then, of course, zeros to add. That was stupid of me. 10 ohms. 10 ohms inverse limiting resistor, and then probably rectified. Yeah, I'll be back in a moment. So I've looked up the regulator IC. I couldn't find anything on the internet about this device. Only some other guy who cracked open this lamp and did the exact same thing and said this is an 08252AB linear regulator, but that's it. So and also the paths are very hard to trace on this minuscule board, so I cannot draw the circuit, but what it probably does is the mains comes in, gets rectified, but first it goes through this resistor, which acts as a fuse and both inverse limiting, I guess, then gets smoothed by this capacitor through the linear regulator, so the voltage stays the same all the time, and then goes through the filaments. And that's all there is to it. So this tiny circuit board. So I measured 10 milliamps on this filament, and it was running at 70 volts. So that means, calculator, 10 milliamps and times 70 volts is 0.7 watts per filament. So in total that would mean this would draw 2.8 watts, the filaments, and probably this circuit draws a little power by itself. So yeah, 3.5 watt is plausible for this lamp. So let's see, 70 volts it said. Let's put that to the test. Yeah, I'm going to set up the power supply. One moment. So I've connected this device, which I used before, and I've just set it to the 12 volt position. The filament is not lighting, so but that would be normal if it required 70 volt. But then again, I don't know the polarity. There is nothing on this filament which would tell me its polarity. So I just made a guess. Let's see what happens if I put it any higher. Let's see if it starts lighting. Or it will go up in flames. But then again, we're at 40 volts right now, and I guess it should do at least something. Oh, it starts lighting, so there we go. I've got the correct polarity. So let's see this filament. It's on this side. It's a little dim, but not bad. The connection is probably not very good. But on this side, let's turn it a little lower. You can actually see if it can get that on camera. Actually, probably not, because it's all. This is a very bad thing to do. Let's see what I can do about it. Let's see if I can put the camera in another position. So here we are in a near dark. As you can see, the filament in the middle is lighting at a little brighter than the left part, and the right part is not lighting at all. So I guess there are 3 groups inside. Let's see if I can count the LEDs. 2, 4, 6. Let's try that again. 2, 2, 4, 6, 8, 10. 10, so 30 of these LEDs in series would mean, or 10 of the LEDs in series would mean 30 volts, but it requires 70. And then I'm going to put it a little brighter, a little less please. Let's see if that's correct. And so there are 3 groups of 10 LEDs, but that wouldn't make any sense. That would mean 30 volts. But then again, if all the 30 LEDs running at 3 volts, that would mean this thing would require 90 volts. So why not put it on 90 volts then? Here we are. Getting a little bright, probably at 71 volts right now. It's a little getting really bright, 74 volts. So let's put it 90. And there it goes. Oh, what is happening? It's doing this all by itself. I don't do anything. What the? What? Is this a bad connection, or is this thing dying, or? Let's put the voltage down. Let's see if it gets back to normal operation. Yes, it does. Would that mean some built-in protection in this thing? I don't think so. So, is it hot? Oh, it's bloody hot. That would mean there's some kind of protection inside. That would be nice. But yeah, I'm just not up to speed with these filaments. I just don't know much about them. So maybe if you guys know anything about them, is there protection inside? I don't know. That would be nice. So yeah, that's probably all there is to these lights. So yeah, this still requires 70 volts and not the 90 which I just gave it, because then it started flickering very violently, and it was also very bright. Yeah, so 70 volts per filament, and that's it. So thanks for watching.